Appreciate it. Excellent. Well, welcome everybody. I'm Sean DeVries from Eighth Light, Managing Director here. I am joined by two of my colleagues for the Agentic Patterns Building a Light Factory. It's part of our A on the Open series, live on LinkedIn. We are going to try to do these series probably every 4 to 6 weeks or so with a rotating cast of characters and external guests and so forth. I'll do some quick intros and then we'll get into the content and we'll go from there. So thank you for joining. All right, we'll start off with some intros. Eric, I'll let you introduce yourself, and then we'll go to Travis, and then we'll get into it.
Awesome. Yeah. So my name's Eric Olson, pronouns he, him. I'm a principal crafter at Eighth Light, and I'm based in Seattle, Washington. A new obsession lately has been hiking in the Pacific Northwest, particularly Alpine Lakes, which isn't a new obsession for many people around here, but an old one. And in particular, I really love when I get to forage huckleberries along the way. A latest project I've been working on is building a repository crawler that's mapping the distributed systems as different C4 diagrams across an enterprise. So off to Travis intro.
Awesome. Sounds good. Thanks, Eric.
Hi, I'm Travis Frisinger, pronouns he, him. I'm the head of Agentic AI at Eighth Light. I'm based in the Denver area, Boulder, technically. New obsession, maybe a renewed obsession here. I grew up doing woodwork, but got a house, got a wood shop again. Building furniture for my house, got to use the wood shop somehow. So far, my daughter's been the main recipient of various pieces of things, but I've got some other projects planned.
I'm Travis Frisinger, pronouns he, him. I'm the head of
And
Agentic.
my latest obsession project would project, I guess in this case, maybe slight obsession would be a concept called hydroflow. It's very much based on once we have these craft principles in the agentic space, where do I need to put my attention as a human? Where do I
Right.
need to pull myself out of the loop? Where can I let the system kind of take over and run with the things that it knows how to do? So an experiment out in the open as well, just like this series, but it's been fun and it's been interesting.
Great. Well, I think you two are a good balance, and I think it plays nicely into this theme of the difference between a dark factory and a light factory. So I'll let Eric kind of get into it here, and then I'll let you two obviously kind of play off of each other as we go through. But I think it's a great counterpoint to some of the things we're talking about here around hydroflow. So we'll get into it.
Cool. Yeah. So today at the webinar, we're going to talk about a variety of different things. To start, we're going to start with the problem and the vision. Then we're going to jump into patterns and practices for agentic engineering and share a few of those patterns and examples. And then a tad bit on further research, and then we'll jump into the Q&A. So we'll move into the problem and the vision. So the problem, as Gergely from the Pragmatic Engineer has noted in a recent post that he sent out, are AI agents actually slowing us down? As more software engineers use AI agents daily, there's also more sloppy software outages, quality issues, and even a slowdown in shipping velocity. So the question comes to us, what's happening and how do we solve it? And a bit more about the problem. There's different evidence from last year and emerging this year. So there's the DORA 2025 report talking about how AI adoption negatively affected delivery stability. There's a DX meta-analysis showing that instead of 10x gains, we're actually seeing more like 10% gains. Also, it's important to note that coding isn't all of the job that we do. And a quick few examples of what's going wrong, like AWS suffered a 13-hour outage and due to AI generated code or like a decision that AI made. Also, even the creator of open code in Century says AI produces bloated code that we know is hard to maintain. And then Anthropic's own flagship product shipped a basic bug. So we're kind of seeing it everywhere. If you keep going on.
Sure.
So yeah, and then there's also this concept of the dark factory emerging. So the dark factory, I first learned about it reading Simon Willison's blog. Anyways, and if you go on to the next page. So what the dark factory is in manufacturing, it's a factory that runs without the lights on. It's fully automated without the need of people. And so in software, we're seeing a similar push to a world where AI writes the code, the tests, and ships everything without any people in the process. So I was interested when digging into these things about how we flip that on its head. And so I was thinking, why not a light factory? So instead of focusing on removing engineers from the loop, how do we make the loop worthy of our attention? Agents can embed proven practices and guide us towards clean architecture, handle the repetitive work, and also generate 99 or I'd say 100% of the code. But as engineers, we can really focus on what requires our deep thought, innovation, and responsibility. So that's really been the focus of this exploration and just continued passion. So as we keep going. Some patterns that I'm going to discuss today that have been emerging as I'm thinking about a dark factory and just in general, my agentic engineering patterns that I'm going to discuss are things like content curation, one of the most popular ones that we've heard, context engineering, newly branded term harness engineering, and we're going to discuss like what an agentic harness is. Then there's the coding loop. The coding loop that I use is one that uses RPI or research plan implement. Implement really focuses a lot on TDD. And then the final pattern that I'll be discussing is reflection, which really helps kind of compound the learnings of the whole loop so that we can continue to have a virtuous cycle. And so why I'm interested in patterns. As a young engineer, I got pretty obsessed with the kind of pattern language, and Christopher Alexander in particular, who's an architect, the author of A Timeless Way of Building and a Pattern Language. And this quote rings true to me. So the more living patterns there are in a place, a room, a building, or a town, the more it comes to life as an entirety, the more it glows, the more it has a self-maintaining fire, which is the quality without a name, which is a thing that Christopher Alexander was searching for. And before we jump into the patterns, I just like to think about the software we generate and think also about similar things, like what is the quality that we're trying to build? What is the real thing, the spark and fire that inspires us and hopefully inspires others to use our software? So I really think we're at a turning point, and hopefully we'll continue to see great gains in keeping the engineer in the loop. So let's go into the patterns. So the first one's content curation. And content curation is interesting. It's just context engineering. There was an interesting human layer article that inspired me to start using RPI, but then also had this great content that was like the quote saying, the contents of your context window is the only lever you have to affect quality. So you could imagine that as a function of the output quality being correctness, completeness, size, and trajectory. So moving on to the next slide, if it is really the only lever, I'm going to suggest there's other levers, but it's probably the most important. How do you use it? So one way that you use it is through layered documentation. So as we're working inside of agents, we can see that there's an agent's MD, and there's different layers of it. So there's like your organizational layer, your global layer, there's in your personal settings and files that you can then go and implement. Then on a project basis, you can have your Claude MDs in your project. And then you can also start to scope it down to sub-modules or sub-projects, or inside of a mono repo, you might have one of the repos inside of it. So other pieces that are interesting around context are things like architecture and testing methodologies, which you can document inside of ADRs and testing strategies inside your documents. And that helps give the agent the tools it needs. And you can reference those inside of your Claude MDs. Other pieces are things like skills, which we'll talk about more, and I'll be showing in examples. Hooks, which are really important, that are parts of the life cycle. I'm also going to talk about those more in depth. Subagents. Subagents allow us to spawn multi-agent orchestration, which we'll also talk about. And with that, you can give it particular prompts that give it clear context for those subagents. Then there's MCP servers. That was the hottest topic for quite a while, which is really just the API layer on top of external data sources. And then context rot, context anxiety, a lot of interesting things there. So just keeping track of how much context you're using, when to clear it, it's a really essential lever to making sure that you have agents create the output quality you're looking for. So I know I'm talking fast, but
good.
yeah.
Just a question on context.
Yeah, please.
So how as an engineer am I going to know when it's time? Was that something I delegate to an agent? Is that something I'm just keeping an eye on? Like, I find sometimes I'm really tuned in. Sometimes maybe I drift a little bit because I'm just riffing really hard. You got any tips or advice there?
Yeah, I mean, I guess like to me, I think I'm going to kind of touch a bunch of them inside of the lecture or the webinar, but uh, yeah, I think at first you should just start with like initializing the repo with your CloudMD no matter what. And then the other pieces is just like reviewing when you see there's friction, when you think that things aren't performing as quickly as possible, when you think that it's not solving something properly, when it's a bit confused. Those are all times and triggers for us to think to ourselves, hey, how can I improve both the harness, which we're going to talk about next, and the context that I'm giving it? And so I think understanding you as the validator of the quality that it outputs, that then is this big trigger that, hey, look, maybe I can start using some of these levers to help improve the quality.
Okay, so by staying the human in the loop in this case, I'm able to really tighten that feedback cycle to Claude around how to manage his context better.
Yeah, that's the basic time that I'm thinking about it. And then there's also, I will talk about reflection skills later in ways to then have Claude go in and suggest how we improve our loops and improve the context itself. So also inviting in Claude constantly to be a thought partner in all of this.
Nice.
Yeah.
Very cool.
And so moving on to the harness engineering side of the house. So another buzzword, there's all these new buzzwords coming up all the time. We're living in interesting times. And so harness engineering, like what is a harness? So first off, Claude Code itself is a harness. It's a harness it's an agentic programming harness that's for the models. And we have a bunch of other type of agent harnesses. The harness that I'm interested in is more so the external harness that keeps Claude Code on the rails. So you see in my little quick drawing that I did. And those are a variety of things that keep it bouncing around non-deterministically, trying to hope that it's going in the trajectory to produce safe and productive code. And so what those consist of is really feedback loops. It's like the tools and the different processes that Claude can run so that it can understand if something was correct or if something was wrong. And in practice, that could be things like tests, strict typing, linting is really powerful, structure testing that I thought about a lot, but I didn't actually implement much, but is really powerful. Then there's tools. There's this, which I'll talk about in a second. Decision records as an architect throughout my career, I obviously love ADRs. And so Markdown ADRs is also really great to then have all those decisions and also let Claude know the decisions. And then context, as we're talking about context and curation. So if we move on, I'll talk more about a variety of other things. Hooks is also a really great piece to this puzzle because the harness only works when it runs. So how do you force that feedback loop, force the triggering of it? And some of the hooks that are in our toolkit are things like Claude hooks. So you can run, they run inside the agent loop. There's pre-command hooks, post-command hooks. They run shell scripts. They can also inject context. There's pre-commit hooks. And so pre-commit hooks just being hooks that you do right before you commit a branch. You can force the linting, the type checking, all your fitness tests. And code review hooks are really powerful too. So then forcing Claude or other agents to come in and review your code. And so back to kind of that point, I really like this quote from Michelle Hashimoto, who was the co-founder of HashiCorp and Terraform, which is every time an agent makes a mistake, engineer a solution in the harness so it never makes that mistake again. And that's really inspiring. So continuing to keep track of these kind of code smells or this friction to quality, and then how can we continue to like innovate and use Claude as our partner in figuring out ways to keep it on the rails and build higher quality software. So that's really where I see hooks and the kind of virtuous piece happening. And then I think there's a couple more slides on this showing it in practice, and then maybe we can talk about a little bit about it. So
Sure.
in practice, a project I'm going to talk about throughout this webinar is Code Cohesion. It's built by Paul Rayner, who's a mentor of mine and the author of a book on event storming and a founder of the Explore DDD conference that's based in Denver. There'll be one this year at the end of the year. It's like one of the main or the main software design conference in the United States. And so people should check it out because this is really an amazing time to be a software engineer and thinking about domain-driven design is having like its third coming with agents, in my opinion, but maybe I'm a bit biased. So code cohesion's like this cool project that I saw Paul drop, where it's like an open source 3D visualization tool. That's goal is it renders code as a solar system, but the goal is really to analyze code cohesion bounded contexts to help with architecture evolution. So we'll dive a little bit more into it. I mean, there's lots of details to it, but if we go to the next slide. So I took the original vibe coded project and then I applied some harness engineering practices to it. So I took the main TS, which was about 3,000 lines of code, and just put some Rails on it. So that started with some architecture fitness function tests to kind of force us to not have God objects, which are just like tons of lines of code in a file. Also just adding in basic test coverage, focused more on Gherkin and ETE tests, added in TypeScript strict so that we add strict typing. I know that's a hot topic in engineering, but type safety is really helpful with agents. And ES linting, and then I refactored it as a monorepo because I had two different projects and I wanted them to run easily as a monorepo, and also focused on building out the Claude MD. So these things kind of, again, started to form the harness to make it easier for me to evolve this code base. And on the next slide, I think I talk a little bit more about some of those levers in the harness.
Real quick, TypeScript strict
Yeah.
is a tongue twister. I just want to point that out. I tried to say it 5 times fast. I was trying to say it in my head without saying it out loud, but I couldn't. I had to practice it. It was tough. So you weren't getting through it on the first try there, Eric. Nice work.
One question, just briefly. I noticed there's no like CI or anything. Does that factor in as well, or you just kind of focus on-
Definitely. I mean, I haven't been focused on it, but it's essential. I mean, it's like one of the biggest pieces to the puzzle. Beyond like continuous integration, continuous delivery is huge. Like that's the goal for all of us. And so inside of this, there's the basics that I was talking about. Observability is also this massive piece, which when you release things in production, you really want to have tons of observability. If you've been working in this industry for a long time, I don't know how many times I've put in tons of logging metrics and then I don't read most of them unless there's a big error. Now we have our lovely friend Claude and his bot army of sub-agents that can help us read that much more efficiently and also continue to refactor that. So it's extremely important because as we continue to rapidly deploy software, it's going to get out into the public quicker. We need to use all the levers that we have inside of continuous delivery and continuous integration to build in those gates. But I'm really interested in like, how do you shift more of the responsibility on the individual engineer that's building it and collaborating with Claude, so that then you can just kind of build in that harness, build in those guardrails, do a code review before you even push anything, and really understand and be responsible for what you're pushing. And then if you invite in someone to do the code review, hopefully the code review can be much lighter. I heard a talk with an Anthropic product manager of Claude Code in an O'Reilly conference where she was talking about, it's like the responsibility of the individual engineer, but and then all the different code reviewers are doing more light code review for like just red flags and for code smells and for things that are going against design patterns. So kind of really leveraging, instead of reading all the code and understanding how it works, the engineer is supposed to understand that, especially juniors, is what she was saying. And hopefully in the future, maybe we can get away from that. But their goal of the review is really kind of to use your reasoning to make sure that it's like logically and structurally and architecturally fitting into what you want to ship. And so
up a layer of abstraction, less in the detail, more about architecture.
And more thinking about, exactly. And how it works is also a product thinking mindset, right?
Sure.
So understanding like your customers and the usefulness of it and whatnot. But I haven't really dove into it in this first version, but I would love to do another session where we dive in deep on continuous delivery, observability, canary deployments, rollouts, like using things like Kubernetes and whatnot to really build out kind of a fail fast methodology around it.
Right, because I think we're in this age where, it's all about understanding how to use it to write the software. But I think that's kind of the second wave that's starting to appear on the horizon, is
The
Got
biggest frictions are now upstream and downstream, right? So
exactly. How do we lean into the observability, the CI, stronger automated validation, the things that just allow us, to that point to keep pulling up the layers of abstraction. And I find it tend more towards a product mindset, right? That's where a lot
yeah,
of the work I'm doing lands me. It started here, love this idea, but I was like, okay, how do I shift more to like getting experiments out, building things that I want to use, and less about crafting the software.
yeah, yeah,
Yeah.
definitely seen a massive pivot in that. But yeah, I guess for me, the harness is just like, can we save as many tokens as possible? Just along that, like, can we keep streamlining the code creation? Then we can then focus a lot more of our energy on those other areas.
Right.
So yeah, so then the next step is diving into this RPI loop, or the research plan implement workflow. And so in this, this also came from the Human Layer article, and I read it originally from um, something that Angie Jones posted, who was at Block, who also helped release Goose, which is a cool coding agent that a lot of people are using to build different factories and dark factories, minions, whatnot, that you've heard from different things on the internet. So yeah, but RPI is a really interesting set of things. And it reminds me of what I've heard people talk called the ODA loop, which is um, observe, orient, decide, act. This is a bit of a different spin on it. So basically, the first step is research. So go in, deploy Claude to do multi-agent research of the code, and then also to go and validate different ideas by doing web searches. I was inspired a lot by early deep research and the findings that I was having with
Mm.
Claude Code. And so then I pulled in that and like asked it to interrogate it and ran it through the loop a few times. So it kind of does this idea of context folding. So it'll go and grab all these different contexts. It used to be a bigger problem when we had a smaller context window. Now we have a 1 million context window. It's a little better, but still, I'm trying to keep the context minimal so it stays focused. It folds all those things together and gives me one research artifact, which then I review pretty closely. And then the next step is planning. And so then how do you actually implement that research? And so it goes in and comes up with a plan to implement it, and then also goes and creates a task graph. And the task graph is really important to me. I'll talk in the next section about multi-agent orchestration and why that's important. And the final step is then, once I have a task graph that allows me to parallelize subagents to then go do this work in parallel, I go through an implementation phase, which then actually spawns them and focuses on TDD to implement the code.
Interesting choice in TDD. I get we're a craft company and you've got strong history with craft, but like, what's the thinking behind TDD versus maybe just letting it write the code and then test it?
Yeah, so I actually have a whole section on that, so
Oh,
I'll be
perfect.
diving into
Okay,
that.
I'll
Yeah,
let you get to it then. Sorry.
yeah, and then why that's like really helpful. Yeah, but jumping in just real quick, yeah, and then let's talk about the Travis more. Yes, I am biased also, especially as Eighth Light, where you're like kind of a TDD shop, but then in general, there's also lots of interesting things to bring up about that. So just showing it in practice, just to show how it works, going through this research RPI loop, just launching Claude, going in, using the slash command from the Light Factory Praxis plugin. So what I'm doing is asking it to change the panels that are floating currently in Code Cohesion into a left side collapsible menu so I can see the whole thing and explore it without the panels being in my way. So pretty simple, pretty straightforward. What it then does is it goes and dispatches the parallel agents like I was talking about. You'll see them show up soon. 2 are launched. There's panel inventory. It's going to figure out all the different panels to move into it. It's going to explore the panel state management, the viewer in particular, and then also it's going to send out a web agent to go and check out like what are different side panel patterns. And it comes back with all the different research, and then it folds that in to one markdown file for me to review. And so I'm using this plugin called Planetator. So it pops open the plan and something that I can annotate. So it makes it easier for me to read. So I go through, read the different plan. In this example, I was just doing it for this webinar, so I'm not actually reading as much as I should. So I'll scroll down, open questions, I'll leave some annotations saying I'm not interested in a lot of these different other suggestions and just want to focus on the basic plan. But to me, it was a bit of looks good to me. So we move on, and then it will go and send the annotations. And then after that's done, it creates the artifact. It says it's good. This is the point where we can say, have I used up a lot of context? Should I clear my context and go and start with a fresh context window? And I didn't need to because I was only using 95% context, but you can see in the bottom. And so then it forces to go plan tasks. And we can talk about the clearing soon. Travis, I don't know if you want to talk about that.
Yeah, I was going to ask, but I'll let you carry on.
Yeah, just because this is a video that I have to talk over. So real quick, the plan tasks is going in and it's exploring the research, and then it takes the research and it goes and generates the plan to implement it and also the subagent graph. And so, yeah, I wish I could speed this up a little bit, but basically it's going to go.
I'll speed it up.
Okay. We'll do more than 1.25 because I'm a fast talker.
You wanted a 1.5 or 1.25?
Yeah, 1.5 is good.
Okay.
Cool. And then, so again, it's going to go through, bring me this plan. I'm just scrolling through it because I'm just showing how it works and saying approve. So now you see it goes and creates this task graph. I'm using Yax. I used Beads before, which is by Steve Yegi. Yax is by this guy, Matt Wynn, who's did a lot of work on Cucumber, maybe founded that. So I don't know all the details, but is an inspiring piece of work. And so then I'm just accepting it, and it'll go through, generate the task graph, and then I move on to implement. And so implement is actually going to be implementing the task graph. Yeah, and so we don't need to, it'll just kind of stop soon, but basically, and then I'll talk about implementation a little bit more with TDD. So you can just cut this now.
Sure.
But Travis, yeah, questions about that?
So you said you could choose to clear the context or not. Like, do you find that you get better results if all three steps are done in the same context window, or if you clear per phase, or is it kind of
I
vary?
clear per phase. I mean, but I think I was noticing it more. It was way better clearing per phase when the context window was 250 tokens, 250,000 tokens. Now that we have 1 million tokens, and it also depends on like where you're working, right? So at the job that I'm working at right now, the client that I'm working on, they have lots of different business rules and their context is quite heavy. And so it eats up tons of the context window. So I find myself wanting to clear more working on those different projects. But whenever I see it rise up above 50%, I'm ready to clear the context because I'm just not interested in it going on and getting to the context anxiety place or being clouded with the other context. The whole point is that I'm collapsing the context and trying to keep it focused. So,
Okay.
yeah.
It's just that reduces hallucinations and some of the other variants that we might
Exactly. I just want to keep it as focused as possible on the Rails. And then it has all these artifacts. And so the whole point is you can save the artifact, then keep it focused on the task. That's the artifact that then you can go in, refines your prompt. So you don't have to, yeah. And you see it happen tons with, it has this whole context compaction, which sadly doesn't work well. Like once you have your context gets compacted, then you start to see massive problems and like less reliability because what it's doing is it's trying to be smart about compacting the context, but it could skip some important instructions, right?
Yep.
So real quick, these just show again before, and then if you go to the next page with the floating windows, the next slide will show it collapsing. So that's what's generated. And then we still have our solar system, which looks really cool, which I'm not explaining or showing how this actually would help with legacy modernization. That's something we're still exploring, but it is really interesting to see how code evolves over time. And if we were going to play this longer, but I don't want to play it longer, you can go see a timeline view where then you could see all the different Git changes over time, which is really interesting because then you can start to correlate the changes in commit histories with like what is the coupling and what are the features. So it starts to show you multiple dimensions of a code base. So you can start to understand these ideas of fracture planes which is a term that came up a lot in team topologies. But where you can split code is interesting to me because it's not maybe as intuitive as just like, oh, I want to split it on a simple entity, right? It's much more complex than that. It works a lot more in active words and events than in static concepts. So
Yeah.
we can move on. So now back to TDD. Why TDD? And then in particular, why not red-green refactor, but red-green validate? So we've seen I'm not going to read this quote, but we've seen like a lot of people posting that TDD is considered a superpower in agentic programming. And as we move on.
Mm-hmm.
I would say in programming, period, but that I'm a bias there.
Yeah, totally. Yeah, but it also has a bad rap. A lot of people have been pushing back on it for a long time. So, but I do think there's quite a good resurgence here. So, and there's lots of good reasons why. So context isolation, again, context is our only lever, is a core principle. And so the main idea behind this is that you have a multi-agent TDD. So you have the first agent, its only goal is to implement a test that fails for this feature. So it'll go and do that, and it fails. Then the next one goes and makes it work, implementing the simplest code. And then the next one goes and validates everything. So this is what structural guarantee against what Beck calls the autological testing trap, where agents delete or weaken tests instead of fixing implementations. That's really important piece to me. So if you keep going on, I think I have some other slides to talk about it more. So on top of that, then there's multi-agent orchestration. This is where I'm building out these subgraphs. This is about the whole reason that I do the planned tasks is so that I can have a persistent subgraph of tasks that then if a sub-agent fails or if I see it spinning too much and I'm just not happy with it, I'll just kill it. And then I'll clear context and I'll ask it what went wrong. It'll go and review what went wrong. And then it'll go and correct course, which I find. Now you could just do it with a YOLO Ralph loop, and then it'll wake up in the morning and do that. But, there's a variety of ways to do it. But I'm pretty obsessively monitoring these things when maybe I shouldn't be. So anyways, and then parallelism without chaos, you can force in human review gates, and it also makes sure that it's observable because it logs all the different actions that's happening. So if you move on a little more. So then there's the idea of validate versus refactor. And so all of these pieces really come back to this idea of me as like recency bias. So we all have biases and heuristics that we use all the time, like shorthands and whatnot. We also see them in agents because it's the idea that the agent has a context window, and the context window is what it understands and what it knows beyond its basic training. And so then if it already decided that the answer is to do A, B, C, that's the code it knows it's seen. So it's going to write tests for that code. And then the kind of problems it knows already. And so the nice thing about breaking it up is then it thinks about the test first, then implements the code, and then you clear your context between each because you have a sub-agent. And then you go through and validate it. So it won't be, and they each have their own tasks of only validating. So I think the next page might go into a demo of it, but do you have questions about that, Travis?
Yeah, I mean, I like how you're bringing through the same context management concept where it's isolated
Right.
steps each part of the way there. I think that's really important because that's where I struggled when I was trying to bring this concept over into the work I'm doing. I actually ended up installing your Light Factory and taking this because it was so well done. I was trying to get it to like, maybe more instructionally go after it, and it would often fail on that step. So this has been really wildly successful for me in the way I'm tackling it and increasing the quality of the output, just like I would expect in real world coding tasks. That'd be my experience with TDD is like it's just
Yeah. But we can clear that context as humans, right? Like it's basically like, I'm just going to focus on writing this test. I'm going to write the test. And then you might take a break or you might then implement it. There's also interesting things we did as humans, though, like where I would write a test, and then I'd implement it. And then I'd be like, oh, I did some of this TDD, and then I'm just going to blow through the rest of it because this is easy now. I kind of have my grounding, and then I'll
right.
come back and write other tests later, right? So yeah, and then maybe again, we missed some different problems that we've missed due to our biases. Again, we have recency bias also. So there's just so much interesting things we can do if we give agents focused context windows and tasks to then come and really leverage them to show our blind spots.
I like that though. Modeling how we as humans interact down into the agentic space really feels like an unlock here. Like not just thinking of them as these magic genies, but as
Yeah.
partners in this thought process.
Yeah, and I think a lot about just in general, they're built on language models. So a lot of the different things that we're built on with language also becomes, different problems. They can just run way faster and comprehend language a lot faster than I can. So if you jump into this demo, it just kind of shows the implement phase with the TDD section. My original demo didn't actually do TDD because it realized that the task it was going to do was too simple and it didn't need to do TDD, which is great when the agents do that. So then here you saw that little red flash in. The Praxis plugin is in Light Factory is going to do the test phase. It has spawns sub-agents to do each one of the tests. And it builds them and it makes sure that they fail. So cool. And then I'm also using cheaper models for things like this, which is important. So I'm using Sonnet for implementation because the thinking side, the kind of bigger brain side, I'm using Opus for orchestration and reasoning. And then I use Sonnet for implementation. And then really simple things like run the tests, I just use Haiku. Next step is then now it's going to go and implement all of the different tests and then run them and make sure they work green, which is cool. It works. Great. And it'll do these things, since we're using a task graph, it does these in phases. So you see P2 there is phase 2. It can parallelize along the phases, knowing what's blocking and not. And then last but not least, it's running the validate, which is running linting and running the full test suite. So it's not focused only on executing that one test, but did that test break any of my other tests? Did it have any side effects and things like that? So it helps us continue just to refactor and keep it in scope of the work it's doing. So then if it breaks something in that small scope, so it just like really just trying to take the iterative development practices that we've learned to love, that we've talked a lot about in extreme programming, that's evolved in Agile and whatnot, really turning that, enforcing that with the agents to do it. Again, the things that worked well for humans, I feel like work pretty good for agents.
Do both of you, it's a bit of a loaded question because I think I know the answer to it, but it's so much cost effective now to have higher code coverage than it was before, right? Because before you were probably burning a number of different cycles for a number of different people's bandwidth, but now, especially when you follow the patterns that you're mentioning here, Eric, of isolated agents and keeping your context windows small, keeping your token budget small, and just doing that handoff process. I mean, you can get test coverage almost 90+%, if not 100%, assuming you have all the dependencies and integrations available to you in your dev environment or test environment. Um, I don't see why we wouldn't lean into this even further as we get along with more complex programs and projects and integrations and rollouts to platforms. We're kind of approaching the vision for TDD originally 10 years ago or 15 years ago, right? So it's
We
it's pretty
are.
impressive. Yeah.
There's cool things that you're seeing stepwise gains with agentic programming, which will really unlock a lot of the value that we originally planned on. We're seeing it through the evolution of computers too. I was listening to some interesting thing there that now we can actually leverage all the power of our hardware by throwing agents to use it. And so similarly, these patterns and practices where maybe we weren't able to fully leverage them. I think code coverage is a particularly interesting problem. I've chased the 100% code coverage a lot in my career. And in the end, and then this is also a reason that TDD is and unit testing is knocked down a lot, that you can have thousands and thousands of tests that don't necessarily catch the bugs. So it's not only the code coverage, which I wish it was that simple. It's also the test quality and then also embedding the behaviors that you want to do the end-to-end testing, which so that's why I'm interested as a further research topic, digging more into BDD, and how can you make that more resilient? And so, yeah, I think it's a super interesting space. And then to add on top of that, there's this whole other interesting side of it, which is digital twins, which is
Right.
that we used to not be able to test the full integration tests end to end quickly. They were expensive. You would go and throw it in production, then all of a sudden it would fail because like there's a new version or whatever. And we've had all these different things to do that, like contract testing and a variety of different ways to solve this. But now you can start to build out, since it's cheaper, build out complete mocks of the digital twins that allow you to then simulate better. So it's a really interesting time, I think, and I've yet to see things fully tuned, and I'm sure it's people are throwing buckets of money at that. But yeah, I'm really excited to see how TDD keeps evolving, automated testing, and
Right.
yeah, it's super exciting.
Well, for me, it becomes the standard. Like it might have been a bar to reach for in the past, but like every project I have has like a TDD. It's TDD. It's got linting. It's got the C. It's got all the things that we consider best practice because it's cheap to get there.
Yeah,
Which, to your point, unlocks the next phase of things. Okay, cool. That's cheap to get to. Now, how do I do that higher level validation? How do I
yeah.
ensure that like the system's actually pretty solid with these changes I'm about to release?
Yeah. And we see these problems explode everywhere. So like in the industry, it went from like everyone building monoliths to then there was like the big push for microservices. And then all of a sudden what you did was you took your problems and you distributed them across a distributed system. And now you have to test distributed systems. And then there's modular monoliths, and then everyone's really into monorepos now. So you'll just see continue to see it in the test problems will continue to come. But this just goes and describes the same thing I've already talked about, so we can skip ahead.
Cool.
But yeah, and then the last but not least, and it's my favorite drawing that I did, just FYI, I got my little PBS face there reflecting in this window. Just want to point out,
Very
pat
nice.
myself on the back for that. So anyways, it's reflection. So it's this, to me, it's like this key piece, why I called the plugin praxis. It's just a key piece for continuous learning, right? And so it's like useful for all of us. It's like we need to do in our industries right now is the time where we have to do so much more learning with the whole ground shifting underneath us. But on the same time, we can leverage Claude to help us inside of this practice do reflection so that we can build this compounding cycle. So how do you learn? And some of the most interesting things we're seeing is coming through with this, like open claw, like you have the loop and you save all the different, save all your different contexts, and then you can learn from it. There's the Ralph loop type stuff. It's all about compounding your context and learning. So similarly with your harness, engineering all these different steps, reflection, I have a reflect skill that then goes and looks at a variety of different things that happen inside your session and then offers you advice on how you could improve your agentic workflow. So yeah, it just feels like such an important piece that I want to keep underscoring to everyone I meet. Claude had this interesting thing called Insights that was released that was cool. This is similar but different. I was built it off of it. So if you go to the next slide, I think I have the demo of it.
Yeah.
Yeah. So again, these demos are, yeah, get nice and speedy. I just say reflect and it goes in and it's going to launch. Like I can ask it what to do, look at the Git history or the different tasks that I did. And so I built this with Claude. Claude has this cool thing called Skill Creator. You can see its fun names like Git Historian, Artifact Scout, Context Reader, Skill Inspector. I didn't name those, but that's fun. I love it when it's clever and fun. So then it's going in and it sent out all these subagents to then go quickly read those parts, and it's going to continue to come back and do the context folding. So I don't have to read every single one of the researches. And then it pops up in Implantator, again, my friendly annotation tool. And it offered lots of advice, friction points. It had different learnings, said you should maybe refactor some other God objects that you haven't refactored yet, a bunch of things that I didn't want to do then. But one thing in particular that I thought was really insightful was what I was talking about earlier, which is adding in pre-commit hooks. So it told me, hey, look, you should add in a hook so that every time it runs, it's actually going to run your linting. It's going to run your different architecture tests. So that's, I think, also helpful when we're building these harnesses, is that don't have to expect to know everything up front. Like a new article drops and I go in and say, hey, Claude, figure out all the patterns from this article about harness engineering, take these ideas, apply it to this code base. Do you have any suggestions based on that context? So I'm just continually trying to fold in the learning. And yeah, in the future, I want to have like, I did have different versions of harness testing. I made a whole harness test bench. It was funny. And then all of a sudden Claude dropped its own skill evaluation tool the next day, which so I was like, cool, I guess I won't try to compete with a foundation lab.
Yeah.
So, but yeah, but there's tons of interesting things to learn with this. And yeah, just such an essential piece of the puzzle to me.
I like the
So I just want to,
reflection there is both the session and external information coming in to kind of continue to augment and improve.
Yeah, and I don't think when I say reflect, it's going to go read it out and like go surf the internet. But yeah, that's just me applying it in those.
But no, I'm saying that the patterns at two levels, right? Like it's the
Yeah,
actual
exactly.
skill, and then you kind of doing the outer meta, like, oh my
Yeah.
gosh, like this is interesting. But I do the same. That's why I'm kind of like it's resonating with me.
Totally.
There's definitely been a few articles. I was like, hey, Claude, I really like that. Like, bring it into the
right.
system.
What
Yeah.
Planinator does for me, and thank you for putting this in here, Eric, because I was having this context switching between Claude Desktop and Claude Code. So I'd be doing a lot of research and planning and sort of document generation, whether it be Markdown or otherwise, in Claude Desktop. But I wasn't able to sort of take that and push it into direct feedback to Claude Code. Well, this Planinator kind of bridges the gap there where you can add comments, tag it with your feedback, and that pushes directly back into the session, which shortens the loop of like the feedback planning and implementation cycle. I think it's a cool way to
Yeah.
just short circuit that part of the loop.
Yeah. Someone in the client that I'm working on like had shared that, and I was like, this is genius. This is so
Right.
I mean, there's annoying parts to it and stuff. And if I had all the time in the world, I'd build another version of it. But yeah, like everything. But yeah, but it's so great because I was like doing similar things where I was jumping to Visual Studio Code, opening it up, and then I was like, I don't like this piece of it. So then I had to go back into Claude Code and say, hey, look, change this. But it's nice to be able to like add in a bunch of annotations too, and then submit all the feedback, and then it can like go and run through one session on it. Yeah, it's pretty cool. And so just to round out my obsession with Christopher Alexander and the timeless way of building and a pattern language. And so both these things are not about engineering necessarily, they're about architecture. But so I'll just read these ideas. Like a pattern language isn't a catalog to be applied mechanically. So not just these skills that I'm giving you or whatnot, but it's a generative process. So that goes back to what you were saying, Travis, too. So rather than a product to ship, it's a quality that emerges with patterns that reinforce each other through use. And so just as we're ending up, I want to invite everyone, thanks for attending the webinar, to just think about like, what are the ways that we can build patterns ourselves? What are the patterns that we see emerging that help with code smells, like that are like anti-patterns and quality patterns that improve our day-to-day? And then think about how you can embed those into your workflow with Claude, where before maybe we didn't have the time to do it because we're so busy trying to run through our task lists. How can we use all of our agency and our thoughtful thinking and innovation as humans to build in and enrich these patterns and then share them hopefully in the open so that we can all benefit from what we're learning? And that's just a personal goal in general. So I think last bit is just further research. I'm just talk about a few things, then we'll jump in the Q&A.
Sure.
So yeah, so just further topics of research that I'm digging into that I've mentioned throughout here is things like BDD and mutation testing. Great stuff. Lots of people applying it for great results I've seen so far. But in my past with BDD, I've had mixed results. So that's something I need to keep doing. Patterns for legacy modernization. All three of the next ones are actually about patterns from the legacy modernization. And legacy modernization can be anything from like a VAC system to basically something that you shipped like 10 years ago, or it can also be brownfield. Like I really feel like people talk a lot about greenfield, but I think basically once you ship something, it goes into production, it starts to be brownfield. So really interested in how you apply these different things to understand that, understanding seams. That's why code cohesion was super interesting to me, and I'm going to keep working on it. Others are, knowledge graphs for business context, super cool, interesting stuff happening there. And then this other side project where I've been trying to figure out how to map distributed systems. So really understanding like what are the coupling and cohesion and connections across distributed systems, because you see there's just so much there, like with like Conway's law and how organizations, and then we create our own structures, and then they all have all these contracts, and then how do we actually evolve this more massive thing? So I'm interested in like the solar system beyond the code base itself, but across the enterprise.
Nice. That sounds fun.
Yeah, it sounds fun in my head, and then in practice, it's still
Right. Right.
still a ball of mud that is messy and dark at times. Maybe I need a dark factory for that.
Maybe there's the generative improvement.
I'll share these links. Thank you all that have attended. This will be an archived webinar. We'll actually also have it up on our YouTube channel, kind of chapterized, and we're going to publish it as a podcast for those that couldn't make it, maybe just want to listen to the audio side of the equation. I didn't plan this, but part of the move that 8thLight made from our bigger office to a smaller office, we actually pared back our library collection, and lo and behold, Eric, I have a first edition 1979 Timeless Way of Building by your friend Christopher Alexander
Oh
uh,
yeah,
in
that's
my
the
like
good
the
stuff.
physical copy here. So the book does exist in the wild. You can also obviously read it in a digital format, I believe. But there's some great lessons that
Analog for
live up to,
life.
yeah, great lessons that live up to the title of the book in here that are worth reading and will hopefully inspire your own exploration in this world. But thank you both for the lively conversation and the contribution to the content. There were a few questions in the chat. If there are people that would like to contribute to the chat, please do so, and I will answer them here in the last sort of like 5 or 6 minutes. But one of the questions that actually came up between a few folks that were in here was deciding when to include something in, kind of back to the first chapter, Eric, when to include something in Claude.md versus the ADR, so more the sort of broader agent environment. I think
Yeah,
you answered that a little bit with the reflect, but maybe
I
we'll talk
mean,
about
I
that a
have
little
lots
bit.
more thoughts on that. Yeah. Yeah, and I kind of skim over context curation just because like it's been a hot topic, but it's so important. Again, it's like the only lever, like is what I mean, it's not the only lever, but it's one of the biggest important levers. Um, to me, I actually there's interesting things you're seeing. So a lot of people are saying that, Claude's ignoring some of its Claude MD. People are seeing that, which is interesting. It used to be like earlier versions of the model, I would say they were built off this idea of a AI constitution. And so you would see that they would really focus a lot on the Claude MD, and then as it's getting smarter and more autonomous, it focuses less. In my opinion, keeping as tight as possible is essential. So
Yeah,
really paring it down. And so to me, I end up moving things like ADRs and moving things like architecture documents into subdocuments and linking them inside of the Claude MD, so that then it's like if Claude decides it wants it, it can lazy load that context is kind of the idea that I have with it. And so
yeah,
if there's certain rules that you really, really want to run beyond just context, then you start leveraging hooks and leveraging forcing functions, and then also building tiny tools and figuring out how to build these tools that then can give it a forced deterministic feedback loop. So
yeah,
like that's happens a lot with linting. So for instance, I really loved this talk on the pragmatic engineer where Gergi was talking to Boris, the person who created Claude Code, and he was talking about like he was trying to automate himself out of being the most prolific code reviewer at in Facebook, Meta, and LinkedIn, not LinkedIn, Meta and Instagram. And every time he would see like a problem that he was saying in code reviews like 4 times in a spreadsheet, he would build a linting rule to then automate that. And so you just see that with Claude Code, and you see that with what he founded and stuff. And I think that's just such a massive important thing to think about. Like, how can we force it to the rails? Because Claude will run that every single time, and
yeah,
then it'll just understand. And so structure testing is another interesting thing. You can get these arc unit tests or other tests to say, don't couple across my hexagonal architecture. And you build those tests to then validate that so that you're just forcing the clean patterns on the agent. So that even if it's like, oh, I think I should do this because it's easier, it's like, oh, I can run this test and it tells me I did it wrong. so
yeah,
so yeah, all those different things. But I like to split it out as much as possible. And then I also just think like what's clean and easy for us to read as humans is also going to be clean and easy for a LLM to read. So yeah.
Yeah, for sure. Two more quick questions. One from Graham. He said, I've been finding hooks to be rather inconsistent in firing
Mhm.
due to the nuance of the matcher. Have you had similar experience? And if so, what have you done to manage hooks better?
Okay, Graham. Yeah, good one. Yeah, I have found them inconsistent. I don't have lots of great ideas about it. I think like I try to I try to go back to like how do you make it something that can run deterministically?
Yeah.
Um, so like then the hook can run yeah, and then also like pre-commit hooks and stuff. So beyond like if I try to take a hook and force context in it, it can just take or leave it. What are your thoughts,
Yeah.
Travis? I'm sure you've
I,
been playing.
I would agree. I kind of think of it in a layered sense. Like Claude hooks are, maybe not the most reliable. I try to trim it back to a real small set of things. I use Git hooks. Like I'm really kind of layering in the deterministic elements I'm looking for here. I've got solid CI, so if something really makes it through, CI is absolutely going to catch that and kick it back as well.
Yeah.
Yeah,
I
for
really like
sure.
this Swiss cheese approach too that I read some people talk about where you have all these layers of Swiss cheese with holes in them, and then you continue to layer them on, and then hopefully you start to block all the holes so you have fairly
Yep.
uh,
Right.
yeah. So,
Right.
but yeah, lots of these things are less constantly hair pulling, less deterministic than we
Absolutely.
Right.
want them to be. Yeah.
The last question I think will be one that I can probably answer from Armel, and that is, I know this is a bit tangential to the topic, but I'm curious if incorporating AI agents into your engineering process has impacted your relationship with design teams in any way. There's a few instances recently where design teams have actually started to lean a little bit further into the code generation side, only through the lens of like a Figma make, where it's generating stub React code or something along those lines. But it's also bi-directional. So if you're getting feedback from the engineering team, they can actually send a prompt across to like Figma MCP, the protocol server, and have it generate maybe some updated images. So it does feel like it's evolving to the point where the lines that used to be pretty hard and fast, bold, black drawn between groups of teammates is starting to blur a little bit as you start to get that crossover between kind of design, product, and the business side, almost like the BDD call out that you had, Eric, around acceptance criteria, the business requirements, and even the visual interaction requirements as well. I feel like those lines are really starting to blur.
Yeah, I think that it's really, I mean, it's a really great point. I think they're super starting to blur. I think that a lot of the innovation we're going to see is there inside of the upstream and downstream, like we're talking about. So there's the continuous observability. Charity Majors from Honeycomb keeps talking about that stuff. Really great. Check
Yeah,
it out. And continuous deployment, continuous delivery, and observability. And then upstream is just a whole friction point. Like, I think, the hardest parts of our job actually aren't just generating code. It's actually figuring out what the outcomes are that we want to move, measuring them, and understanding value. And how do we deliver that value? And how do we validate that value? So user research and all the different things that are so essential and design and is more important than ever, and it's going to continue to be more important than ever as we see like our whole software landscape evolve massively, maybe away from us being from computers to physical AI and whatnot.
yeah.
Hopefully not in the dystopian too much Terminator way or something, but in other ways that are more helpful.
Right.
Yeah, yeah, but no, I think it's blending, and I think what a great time to go and use your imagination as engineers and start to collaborate with those designers and like bring them into the fold and like, have it be a tighter feedback loop where we can
Right.
really just go from like idea to delivery and like feedback, customer feedback and learning.
Yep.
It's a wonderful time to be creating products.
Agreed. Well, thank you both. This first edition of AI in the Open, turning LLMs into reliable engineering partners. I think you all just teed up the next topic, our next session, which might be a little bit more of a crossover between, product design and engineering. I think that would be a great collaboration
It'd be a great
session.
session.
Yeah, thank you, Eric Olson. Thank you, Travis Frisinger. Thank you to all that attended. And thank you for those that were lively in the chat. We appreciate it, and we will see you next time.
Yeah,
Thank you,
appreciate everyone. Take care.
Thank you, everyone. Bye.
Bye-bye.